Hi everyone, welcome to another episode of DataStream Live. I'm joined by three space researchers and academics from across Yorkshire. Wendy representing Space Hub Yorkshire and Rami and Raid representing University of Bradford. Guys, it's great to have you on. I just want to go around and get some introductions if that's all right. So Wendy, if we start with you and sort of tell us more about yourself.
Yeah, sure. Hello, everyone. I am Wendy, and I'm now one of the space technology leads at Space Hub Yorkshire. Space Hub Yorkshire is one of the regional space clusters, and we aim to unlock space for people and businesses. That means we help connect people, promoting space technology in a wide range of sectors. And most importantly, we help facilitate collaborations among those who are interested in space. And thank you. Nice to meet you all.
Thank you, Wendy. And Raid, let's move over to yourself.
Thank you very much, Elliot. Hi, everyone. I'm Professor Raid Al-Hamid, really, in Bradford University for many years, working on many research projects, including as well the CubeSat as well, and preparing some Adapt2 application as well on satellite. And we prefer as well to include the AI as well in the design of the front end to make it more energy efficient that can make the life as well for the CubeSat more longer than 6 months. Thank you.
Fantastic. And Rami, yourself?
Well, hi everybody. My name is Rami Kawaji. I'm Professor of Visual Computing at the University of Bradford. So I'm specializes in AI, computer vision, data science, and with a special focus on space missions data. So we do lots of work with satellites, with space operators. So I have the pleasure of doing work with NASA, ESA, and many space organizations. And I developed a space weather prediction system that is currently integrated with NASA's Community Coordinating Modeling Center. So we do lots of research. We have a huge interest in the promoting the use of AI and all these recent technologies for space exploration and creating new space businesses and opportunities.
Fantastic. And Rami, on that, how has computer vision research changed over the last couple of decades? What kind of research are you doing now, and how has that changed since you first started out?
Well, when I first started out, we didn't have these recent AI technologies, so people had to rely on basic machine learning techniques, and video processing wasn't that state of the art, or it was something very difficult to do. Now, with deep learning, with advanced image processing, you can see lots of applications. Just self-driving car is a very obvious application, because self-driving cars is not only that they are doing correct identification of objects in the environment around the car, but they do it in real time as well. So we have more accuracy, we have real-time processing, we have lots of advancements. But if you talk about space, many of these advancements did not materialize yet. So when you put a self-driving car works in an environment that's quite well known I mean, road, what would you find in a road? Pedestrian, road signs, traffic signs, and so on. But if you put a rover on Mars or the moon, that's a totally complex, different environment. So there are still lots of challenges, and future is bright, I think, for AI to step in and do lots of useful things there.
Do you see any hurdles or barriers that might slow down the development of computer vision within space research and academics and self-driving cars? Are we reaching a point where the technology can't keep up with the rate of innovation, or do you feel like technology is keeping up?
Space is unique because, I mean, self-driving car or similar or factory, or you can put as much processing power as you want, but you send objects in space and in Mars and on all these satellites, they have limited onboard processing capabilities. They don't have this infinite supply of energy. So everything we have to do, even if we have these marvelous techniques here on Earth, it's not guaranteed to work out there. So you need something that is simple, something that's suitable for onboard processing, there are lots of engineering challenges there.
Okay. And Rayed, over to you. When you talk about AI and applications in your area, are you talking about computer vision as well, or something slightly different?
Of course, we have nearly finishing usually when a project, usually myself and joint with Rami as well. This is one of the applying as well AI and deep learning as well, using the face recognition plus as well the finger vents and fingerprints as well. Apart from that as well, we extend this one in terms of patient monitoring, and as well we're getting the AI to the level of engineering, which is to the RF side. And why we are doing this? Because it seemed to me the life cycles as well for the satellite, I mean the small satellite, cube or nano, we are thinking as well for the future implementation and development. It is not energy efficient. And it seemed to me as well, we are trying really to apply a new type of technology in terms of, because the main power of the satellite is the source. I mean, the power source that can facilitate, for example, the operation of the satellite properly as well with some base stations on the ground. So we are trying our best as well is to, as I said from the beginning, we are trying as well to build this as well and make it more accessible in terms of we can increase the antenna array elements on the CubeSat, even if it is a small, within, for example, 10 by 10 by 10 centimeter cube. And we are thinking as well to make it more reconfigurable. Not necessary as well, we work on single frequency. We can work on multiple as well frequencies. This is a bit hard as well to be implemented, but at the same time, we need to make it more energy efficient. And this is the most important part of the design model. We need to apply the AI as well and see how energy we can save really to make the life cycle for these type of satellites more longer. Not only that, I mean, there are so many things as well. Is the movement of the satellite as well, the steerable, the radiation pattern is very important as well. We are trying as well to put so many things that is not consume a lot of use of power from the battery or the source as well, or the renewable, I can call it, source that can use, for example, solar cell or something on the CubeSat to generate a little bit of like 10-20% of the power to make it more longer. But still, the AI, it can be used as well to enhance as well the operation to make the energy efficient system can operate on a small device with memory and small CPU. So this is the full idea. I mean, we are playing with the front end where the power is the main part as well to put these type of satellite to operate for more longer time. On top of that, there are so many things as well, because we are, as well, as I said to you, we are putting this as well. This is just sample, really. We have 2 satellites we are building up as well. We are thinking not only 1 cell, we are going to 2 cells and we are going to 3 cells. And we will see as well the AI, even when we put the 2 cells, because we need more space as well for energy efficient. And as well, in terms as well, we are going to change the design of the front end. And we are working hard as well on this to get the required, for example, to help the front end in terms of efficiency and power, to reduce the power consumptions to transmit the data from satellite, for example, to the base station on there.
So are you using AI, possibly machine learning within AI to help the efficiency?
Absolutely, because there are so many things as well. Is not necessary we are looking to the satellite and how much energy we can get. The most important as well, how much energy we are using as well to communicate with the base stations. When the satellite is passing, for example, on the surface of the Earth, where coverage of the base stations is available somewhere else. So this is very important really for us. So we are trying really to invent some type of front end, which is, I don't want to explore the big story, but we are trying really to is a new innovation. Like for example, we are trying really to increase the gain, make it more omnidirectional, and we are going to save the power of the power source which supply, for example, the small satellite like this.
Okay.
So this is the full idea. Yes.
Great. Wendy, over to you. What is it that you get involved with from an academic point of view and over at Space Hub Yorkshire? What kind of projects are you working on at the minute?
Yeah, so I myself is a bit different from the two professors. I focus more on the downstream data, which means the products are captured by satellite. And most of them are satellite images. And because I'm actually came from a geologic background, in the past few years, I use a lot of satellite imagery, or we call them like Earth observation data, to do my research and do the topographic analysis. So at that time, I was quite amazed by like how powerful these images captured in the space could do. And now my current role is more in exploring more on what these Earth observation data could tell us, and also help to promote its applications. So now AI has been applied a lot in we call like the image analysis aspect, because like and actually the satellite image, you could imagine that it's just like a photo captured by the satellites, and they are composed of a lot of pixels. So like the larger or higher the resolution of the image, the more pixel data you will get, which will make the satellite imagery a form of big data that could be efficiently used in machine learning and AI analysis. And AI technology now has been developed to detect the land cover, or the soil health, or the crop types that with AI we can detect them and identify them more quickly and efficiently, which could help like benefits to monitor the diversity in the city or in the farm, or also help to improve the urban habitat mapping, because like AI can now identify like private gardens or paved roads or the tree counts in the city. So yeah, these are kind of the projects what I've been promoting and also looking into.
Oh, fantastic. So just touch on that slightly regarding the urban planning side of the satellite imagery. What was the problem what was the problem before that AI is helping urban planners overcome?
I think one of the things that now we are having, because as time goes by, we have more and more satellite images at the moment. And before AI, in the very early time, we need to like map the land cover like manually, and just but now as time goes by, we have more and more images, and we have a lot of work that people have done or mapped previously, so that these data could be fit in to train as a training material for AI technology. So I think in this era now, AI could help to help identify these kind of data more efficiently and precisely, so that it could help us to get more like real-time data, or like more instant data, and this could help in like a lot of like policy making, or like just emergency response or disaster management, because we now have more instant data, and it's more accurate than previously, that could overcome quite a lot of the obstacles that we couldn't do previously.
Oh, thank you. Ryan, back to you quickly. You were mentioning before in your research, you kept saying we. What is the we behind the
Oh, thank you very much.
Cross-functional team?
Yeah.
Who's
Thank
involved?
you very much. Usually, first of all, I can most of the project is shared as well with Professor Rami. He is as well is the biggest partner as well with me as well on the many projects. Is usually the last one is we awarded in January or March, I think. We are dealing with 6G and beyond as well. This is a new project as well, and there is another 2 project as well. We're carrying on 5G as well, and the other as well on mobile handsets as well, designs. So most of the project, I can call 90% of the project, myself and Rami, we are share it as well all together, because Rami as well is taking the steps as well of the AI and the image processing, and then I take the circuit designs, the RF, to make it more consistent as well to meet the, as I said to you, low power, but we need just to make sure to make the link budget. Wendy, she mentioned something. Is she said as well about the imaging, and we are looking as well for the imaging, but with the high resolutions. So high resolution, it means more data rate. And the CubeSat, when we are talking about it, is a simple cameras, which is, I'm looking as well for, we can go beyond this as well. High resolutions cameras we can handle as well on it. But to let it work as well, to make the system all energy efficient, to reduce the power transmit on the front end, to make the, for example, the link budget, to communicate with the base stations, and we can increase the data rate and push it to the front end. So this is another idea as well. We are trying really to play the game as well on the front end. I know it is complex. It needs money. It needs more appropriate design of the front end. But this is the real challenge as well, is the future, if and only if, when this implementation can be done, I think we can have a lot of things in Yorkshire to contribute as well, to have our own, umbrella to use the new innovation of the front end, plus as well what we are implementing in the AI to have a longer life of these type of satellite. So it's not necessary. And when I'm talking about satellite, usually, as I meant, really, I'm interested in this small things as well. I know LEO satellite, we put application as well, LEO and maybe MEO as well. I work on MEO as well, on some UK Space Agency as well. But in general, nowadays, people more exciting about simple things. Somebody can launch these as well and can do it themselves. But in general as well, we need to make it more innovative. So we are working with AI. We're working with so many companies as well to make it more energy efficient. Same like what we are doing on mobile handsets. The mobile handset as well, when a disaster happened in Pakistan, for example, I can give you a simple example. And the base station has been destroyed. And the battery life as well is nothing. So our project as well, which we have done it in by end of 21, we generate as well a new type of design on mobile handset with, of course, with the Portugal, German, Spain, Greek, big project as well. Rami is as well on the project with me, and all that we need to provide some solution when disaster happens. So this is the idea. Suppose there is no base station can communicate with the CubeSat. What you can do? Maybe your mobile can be done as well if we prepare very well to make the mobile have some kind of facilities really to make the communication with the CubeSat. So this is the idea. So we need to have some the CubeSat or the mobile handsets to be more accessible, not necessary to be dependent on a main base station or main mobile base station or main ground base station as well on the ground. frequencies is many. I can call it from 1.2, 1.6, and then you go to the 2.5 and 5 and 6 and so many things. And again, as well, there are so many spectrum for Ka and Q bands and so many. But still, it's not utilized at the moment. Just a few spectrum, which is make it more simple, more easy, and low cost as well to be implemented. But unfortunately, it's not energy efficient.
Okay, fantastic. Thank you. And Rami, throwing it back over to you, can you explain more exactly how computer vision works? We've heard Wendy's talking about it looking at pixels. It's not actually looking at the images as you and I would see it. How does the machine learning model actually interpret images, and how do you train it to find things that you want it to find and not noise or things that you...
I think the most important thing is to look for patterns. So what are the patterns that you're looking for? What exactly is for? So there are lots of examples. So remote sensing today can be used for urban planning, as you rightly pointed out. It can be used for disaster management. I had a student who was interested. He was from North Africa, and he was interested in tracking sandstorms because sandstorms is a big problem in North Africa, for example. In the States, you have hurricanes, which needs to be tracked, for example. So you have all these kind of natural disasters. I think we had a small project working with the Middle East on things like using satellites to make sure that the crops are healthy, because healthy crops, they produce, there'll be certain color was associated with healthy crops compared to disease crops, for example. So you can use satellites for different kind of things. And as Waid said, now the recent advancements means that we can see not only the surface of Earth, but you can also see different layers. So you can monitor the whole environment up to the clouds, for example. And this can give you lots of wealth, lots of information. The golden question is what you're looking for. Are you looking forward to see the effect of desertation, for example, landslides, flooding? All these things you can use machine learning to identify, because pixels associated with healthy crops would be totally different than pixels associated with flooding, for example. And especially if you compare these recent images or recent findings with previous images, like before the disaster, you can easily and quickly understand the extent of damage that's happening.
Okay. How can you be sure from a machine learning point of view that it's identifying the variable you want it to identify? In terms of, you said there, good crops and sandstorms. How do you know that it's not identifying something else that might be in the image?
Well, machine learning, it depends on how you're going to pose the questions. AI either uses rules to learn or needs data to learn. So it depends how you're going to use AI.
Okay.
So some people, they like to use things like fuzzy logic, where they use lots of rules. So you know that these are the characteristics of a healthy crops, and then you embed it, and then you have to test it. You cannot put anything out there if it's not fully tested. And after you've tested, you have some measure of reliability. We have lots of metrics. I just came back from South Korea, where I delivered a talk on the use of AI for space missions data and for space mission analysis. And a big part of it is how to evaluate, how to put that reliability tag on on the kind of decision you're making. So that's a big science by itself. But we have lots of metrics today. And there is no AI system that can be, nobody takes, if I say that this system will produce 100% accuracy, nobody will buy it. So we have lots of techniques and metrics to evaluate the performance. And this is becoming a well-established science now. And in academia, every paper that's published, they have to follow these guidelines.
It's quite interesting. And when you speak about the applications, it seems like it goes across departments as well. When you talk about it can see through the layers of the Earth, I'm thinking geology, you spoke about weather, meteorology, physics, astrophysics as well. It's quite cross-department, I'm guessing, more so than any other research.
It is, because I think for me, as a data scientist, engineer, the biggest challenge was to try to understand the physical meaning of the data. Because, when it comes to a satellite, you have three different distinct areas of operation. There is the navigation of the satellite. So you have to make sure that the satellite stays in orbit, the satellite is protected from the hazardous environment that it's currently located in, space debris, solar storms, radiation, and so on. So that's the first area. The second area is what Waid has been talking about, communication, how to have better communication with the satellite. And then the third area is how to analyze the data efficiently. And to analyze the data efficiently, we need to have some physical understanding of what does the data really is telling us. It's not just numbers. You put it into an AI, hoping that the AI will generate the decision. There needs to be some basic understanding behind it. And I think this has been the biggest challenge for data scientists when it comes to analyzing space missions data. It's exactly what you just said. People think that you need to have basic understanding of the physics behind it. And I do find this to be the most challenging aspect. It's not the machine learning, it's just understanding the science behind it. Sometimes it's really worth doing.
So would you argue then that a cross-functional research team is ideal, where different people have different domain knowledges and that sort of diversity improves the project as a whole, instead of just having maybe a team of just data scientists and engineers?
Every space project is a multidisciplinary project.
Okay.
So I worked with space agencies before, and in the teams you will find there will be physicists, there'll be space exploration experts, there will be data mission analysts, and there will be AI machine learning people. Because even to do proper machine learning and AI, you need to filter the data. And to filter the data, you need to have a basic understanding of how is the data collected, what is an error, what's not an error. So you need to have this basic understanding, and you need a multidisciplinary team to be behind it.
Okay, and then I've got a question for all three of you, really, and just speak up whoever it sort of resonates with. We recently saw that new government is cutting 1.3 billion in AI and data funding. Is anyone concerned about this, or is it just kind of a headline to try and spur up some sort of reaction? Are you seeing funding within academic institutions available for AI research projects, or is it being cut? That's to all three of you.
On the other hand, maybe I can. On the other hand, UK government as well support the EU funding. So whether as well there will be some another type of funding available as well, can import as well AI or other things as well to support academic or researchers as well in UK. So I know the cut is a problem, but there are so many. They didn't touch so many important as well calls that we can apply for really for it, and assess as well the AI or any other things as well in terms of AI in space or any other type of applications.
So you don't believe that there's a shortage of funding for AI research projects?
No, because there are so many calls open. This is my view. This is my view. I mean, there are main funds calls as well available from other sources as well by the government. I mean, supported by the government. So simple things I can tell you: EU funds. I'm preparing something as well in November. I'm preparing something in January. So this is as well. It is part of it as well. So AI, it could be the heart of the engine. I mean, the innovated engine for the future is. This is my view. I mean, government is not easy really to. It's difficult really for them really to keep us as well away from what's going around as well in Europe or South Asia or North Asia or USA.
Wendy, Rami, do you agree, disagree?
I'm slightly concerned, to be honest, because if you think of other countries and what they're doing, I think the UK is struggling to compete with the rising powers. I mean, there was a time when we were the power hub of the AI and the really, but cutting the funding for AI, I think without having something else to replace it, for me is worrying. I would be far more reassured if there was like targeted goals for like AI in medicine, for example, or AI for satellite applications, or AI for space applications, things that's naturally been associated with the strength of this country in innovation. But just to, so I think this is maybe targeted funding of AI applications, I think, would be reassuring for all of us.
And Wendy, yourself, as a Space Hub Yorkshire representative, as a slightly different organisation, how do you feel about funding and things?
Yeah, of course, I would be concerned that the government decide to cut the funding for AI research and the related support, because I think I agree with Rami, because like most of the countries in the world now put their efforts and resources in AI technology development. So if the UK government decide to cut down on this aspect, that would be quite dangerous and challenging for the whole nation. So I think I will be concerned about it. But if they could support AI in a different way, maybe it's just an act of moving funding, maybe that's what something happened in behind, that might be okay. But if they are really like cutting this funding in the long term, then I don't see it as a good sign. That's my personal view. Yeah.
And going back to Rami and Ryan, maybe a better question for you guys as well as Bradford University representatives. Upcoming talent, are we seeing enough AI talent coming through the student body? Are we seeing people get from sort of physics and astrophysics coming across and learning more about AI and being interested in it? Has there been a shift in that, or is it sort of dwindled a little bit?
Well, I work in a department where AI courses are the most popular courses today. I think young generation, my son is a teenager, so they were born with AI. So AI for them is part of life. Many of them want to learn more about it, and they're really very good with it. I don't see that there is a serious lack of skills when it comes to AI. But I think there is a serious lack of skills in the multidisciplinary skills that AI requires. So it's exactly going back to the point. If you want to do AI for diagnostic of disease, for example, you cannot treat the medical data or the images or the X-ray or the MRI images as just pixels and data. You need to have some understanding of what is the pattern of disease, how does the disease look like, what is the evolution of the disease. So there is this supporting skills that AI scientists needs to learn. And I see that as the challenge today. But definitely there is no shortage in number of people studying AI and learning about machine learning and data science and visualization and all these things.
Right?
Yeah, thank you very much for this questions. Really, is in addition to what Rami said as well, is not only the application on health and so many things as well, security, networking as well, but on the technology, AI as well playing a fatal as well role as well in terms of the new innovation of new technology. So this is another thing as well. I think it will continue. It will not going to stop, really. And usually, I can say I can see as well the work on, for example, my work on the front end in communications, which is completely as well the idea from other things as well in the type of the application of AI. Now we can see it as well on some of the work publication in top journals as well, like for example, communication channels, estimation channels on 5G, 6G as well. But all this as well is based as well on the principle of the AI, how can be implemented to enhance, for example, the 5G and 6G communications we are looking for. So I think it will continue to use the AI in our view of technologies, new technologies, I can call it, a new development of technologies, like, for example, the machines, engines. We can make it more smarter. We can make the everything more smart as well using the AI in terms of not as well. In addition, what Rami said as well, there are huge things as well can be applied to human society, including as well the NHS, for example, there. But as well, AI can support as well the industry and the technology innovation of the machine and so many things as well.
It's interesting, Ryan, that you mentioned 6G, and it kind of reminds me of when 5G came about, and the applications were very much hyped, and it was going to revolutionize the world, and we're all going to be more connected than ever. I don't know whether I'm in the minority here, but I don't feel like it had the impact that we were particularly promised, and some might have become disillusioned with this development of technology. Are you seeing something like that where the media might overhype these technologies and their applications?
Of course, I can say it. Thank you very much for this question. Usually, we work on 5G, and the government as well, Europe, USA, everyone is now, we have base stations, we have mobile handsets on 5G as well. 6G is because we, not me, I mean, so many industries as well and government as well, they think as well the spectrum is not sufficient as well in 5G. So we are going to have the 6G, which is can give more wider spectrum really for us to cover so many services, to cover many, I mean, wider bandwidth as well, with so many things, application we can apply. And I will add something to you as well. We are not only working on 6G as well, we are working on 6G and beyond as well. So we are working on terahertz. On terahertz, we are working on the top of several for example, gigahertz, to enhance, for example, the capacity, which is the main priority as well for us, and a huge as well bandwidth, really to enhance the operation of the network. So the idea is, I know it's challenge. 6G is still in the basis of universities and some industry at the moment, but still as well, when it goes to the market, usually it will have so many things as well, same like what we are doing in 5G. 5G is using as well the 4G base stations, as simple as that. So they change as well the tower, and they put as well the intelligent, I can call it, the smart base stations really to communicate with the mobile handsets. 6G, it will be more appropriate as well for directional. It can hold the data rate from some area and put it to another area. And still as well, 5G is, we are trying as well to communicate with the satellite as well on 5G as well. So this is a new approach as well, applying the 5G to communicate with the satellite, including as well the other 6G spectrum that will be available and is available for us as well to implement, for example, the tab of the front end and improve the antenna array, for example, because we are working on massive, we call it massive MIMO, massive antennas. Is not only one antenna or two, because we need just to generate, for example, getting on higher frequencies, you need to generate more power, really to save as well the power you are pushing to the front end, to make the appropriate link budget with another a communication point away from you. Okay. So this is the idea. So we are going. Market will never stop. Maybe after 6G, we will definitely. I have as well PowerPoint on 7G, which is using the more than the 200 gigahertz as well. By the way, I went to the National Physical Lab as well in north of London as well, and they are working on the 6G, and I'm trying really as well to visit them again because I'm interested on what they are doing. Maybe I can improve the front end as well on the project we have as well on the 6G with the Europe. So it is a challenge. God only know. I hope they are not going to cut as well the cost. I mean, funds for 6G or 7G. I don't know really. We need just to be more thinker as well to work with our European partners and our international partner, I can call nowadays, to find appropriate solutions and to how to improve the communications and as well the future communication with satellite as well. Not only the basic spectrum which we are using at the moment. I know for a CubeSat is very limited. So we need to think on the future. So the future is open.
Thank you. Yeah. Wendy, on that, it's interesting listening to Ryan speak because he's talking about 6G, 7G, and I'm sat here and I still can't get 5G connected to my phone inside.
My daughter is using 5G. I can call you as I can show you as well the difference between 5G and 6G. Like for example, she's using 0.8 gig as well download, which is on 4G. I can see it as well a few megahertz. So this is the idea. This is the data rate. You can make a video call. You can 5G can simply you can give a lecture as a video for every student in a big lab, for example. Not necessary to see you or to see somebody. They can watch as well a real-time video streaming as well with 5G.
That's interesting. And going back, Wendy, then. So I don't know whether you're getting this, but I feel like there's a bit of a gap between academic research, again, like I say, talking about 7G here, and I'm, as an individual with a mobile phone contract and a 5G phone, struggling to get 5G. Do you think there's a gap between the advancements of AI, data, and technology within academic institutions, and then that being delivered to individuals and businesses in the real world outside of these academic institutions?
Yeah, sure. Yeah, I do see there seems to be a gap between, because I think the reason might be that there is not enough awareness in the industry or the general public about how useful these space technology and also like Earth observation data could benefit them. So this is also one of the things why Space Hub Yorkshire exists and what we're doing, because we're trying to raise the awareness of these powerful data and tools to a wide range of sectors, such as the financial or the agriculture sector. And also we're trying to bring those people together and start the conversation to that they understand what the technology has been developed and how they could use like satellite images in to do like their precision farming, because it could help in identify crop types who can save their fertilization and improve the irrigation for farms. And also we are also trying to bring the financial sector people on board to understand how satellite data might help in, for example, the insurance sector. Actually, satellite images might help to provide a more precise flooding model in the future, and also it might be able to forecast like the landslides, or might be able to identify the potential region where those landslides might occur, or where there might be ground subsidence in the city, so that you might need to avoid build something there. So these data could obviously benefit to the insurance company, and also for like the real estate, and or maybe just for the individuals if someone wants to just buy the house or something. So we're trying to just to narrow the gap of this and trying to that the general audience and a wider range of people get involved in the space data and know how to use them. And that's what we're doing.
It's interesting you mentioned insurance companies, because if you think space tech and AI in space, I never would have thought insurance companies. So for those people watching this thinking space tech, AI in space, it's nothing to do with me or my business, what would you say to those?
Well, I would say that they're wrong. There are actually a lot of things that space technology could benefit in your business, and there are actually lots of resources out there, and lots of institutes such as the regional space cluster, like Space Hub Yorkshire, that you could just reach out to them, and then because we got a lot of people from the insurance sector and also like agriculture sector reaching out to us and saying that they was wondering whether space technology or technology could help them doing blah blah blah, and we help explain some technical points of view to them, and we also help them connected with like space tech firms or AI tech firms to help solve their problems, and they realized in the end the space tech could help them. So I mean, it's definitely there's lots of resources out there and lots of opportunities out there. So
If I can go back to the insurance company, if we wouldn't mind. I do lots of work on space weather prediction, and that is the prediction of solar storms and what can they do to the infrastructure, satellites in space, or the infrastructure on Earth. And many of the early studies on space weather prediction and their effect were funded by insurance companies. Because if the solar storm happens and you've got two satellites knocked out of space, or there was a huge damage done to a power grid, or there was significant delays in the aviation industry because of it, all these things have serious insurance consequences. So space is becoming part of our everyday infrastructure and civilization now. It's difficult to imagine life without internet, without messages, without communication, without all these things.
That's fascinating to hear how a solar flare or some sort of space storm could impact the insurance companies here in the UK. You never really put two and two together. It's quite interesting to see how
I
interconnected.
think one thing to keep in mind is it's always been there since the beginning of humanity. But as now we depend more and more on satellites and on space. So the number of satellites keep growing, and we also depend a lot on electricity. And all these things can be affected by solar storms. So as we depend more on technology, somehow we end up being more vulnerable, which it shouldn't be the case, but this is how it's the truth.
Absolutely. So I'm conscious of time. So what I'm going to a two-part question for each of you before we finish. We'll go back to Wendy and we'll cycle around. Wendy, I want to hear one application of space tech AI data that you're really passionate and want people to know more about because it's having great success, and one area where you'd like more research or more investment or funding to investigate more. So what areas are thriving and are very successful at the minute, and what areas are slightly weaker and need more attention, in your opinion?
yeah, I think one of the thriving area might be those in the agriculture, because now I think a lot of people already taking the use of satellite image to do I call like precision farming. So a lot of them are using the Earth observation data to detect soil health and crop crop types, and also try to predict the crop yields. And they are and there are lots of successful cases in that. So like farmers can reduce their costs in fertilization and also improve their efficiency to grow their crops and make more profits on that. And that also benefits the financial institution. Yeah, because when the financial institutions are making loans for those farms, and if the financial institution are focusing on their ESG reports, and they will try to collaborate with those farmers that could help them feed their ESG reporting, and that's all making progress, and that looks quite well. And the area that I would hope to thrive more might be related to the disaster response or like a natural disaster management. Because I know, it's actually a lot of technology now could be using, like, as I mentioned, like predict like flooding or just map landslides, and maybe also heat wave as well, and also like wildfires. But I mean, it's because of maybe the climate change. These kind of natural disasters are happening more frequently and more randomly and more severely in every part of the world. So I would be very keen to see more well-developed technology that could help us do like real-time monitoring of these disasters and could help more in such as like use space technology to do like real-time evacuation if needed, or to help in the government, or like the some blue lights institute to do more efficient management when disaster happens, and also hopefully could also prevent those disasters if the AI model could predict more precise floods or wildfire distribution. So yeah, that's my point of view.
Thank you. And Rayed, same question.
Yeah, I think Wendy, she covered a very important as well issue of applications as well is early detections of disasters, which is a brilliant ideas as well. I think we need just to have another thing as well. I mean, this week is we have seen the fires as well in Greece, and there is no early warning as well for the people. And the people they say it as well on the news, and they have so many problems as well. So this is one of the application probably is signed for the early detections of these type of disaster. Not necessarily a fire. It could be flooding. It could be flooding, same like in Pakistan or something. So there are so many applications, but at the same time, we need to think as well how we can use these type of satellite, for example, in terms of AI as well, and the data we are collecting, that we can share it all together. This is another ethical problem we have. Maybe is a big issue as well. I'm thinking everyone want to have his protected data as well. How we are going more broader as well to think these type of data, it could be in a way to be used in a very big system in AI really to facilitate the problems. So there are so many things. In my view, I am radio frequency engineering. Usually, I'm trying really to make more accessible link communications between the satellite and the base, any mobile or a base station on the ground. This is my biggest intention, to keep it more reliable communications. We are not going to lose it. We need just to keep it as well in our hand. And later we can grab the data and we do it to the machine learning. So this is the main things I'm thinking about it now. Thank you.
And Rami, to finish.
So my first thought was exactly what Wendy mentioned, which is Earth observation and the different applications, disaster management, environment, climate, and all these things. So I have to come up with new ones now. So a thriving area would be, I think, the prediction of solar storms and how can they affect our infrastructures. And an area that I would love to see more of is the use of AI to improve our understanding of the solar system and for space exploration. Because we have lots of satellites, lots of space missions, like the James Webb Telescope, lots of the Mars rovers, and providing lots of data. We are data rich, but our understanding of the universe can be seriously enhanced if we use AI. That's it. Thank you.
It's quite a chilling thought to finish on there, Rami, that we're so dependent on satellite technology but know nothing about space. But no, thank you.
This is
yeah, so thank you all three of you. Thank you all for coming on. I really enjoyed all of your insights into different AI applications across the board. So thank you very much.
thank you.